What mathematical measurement error once occurred when a spacecraft reached Mars?
The Mars Climate Orbiter spacecraft, a joint effort between Lockheed Martin and NASA's Jet Propulsion Laboratory. JPL, was supposed to go into orbit around the red planet on September 23, 1999. Instead, the Martian craft lost all contact with Earth. After much deliberation, a review panel for the incident came to a disconcerting conclusion. A thruster error developed when project teams used different measuring systems for the navigation commands. NASA used metric units. Lockheed Martin used English Standard Units, and no one caught the discrepancy. To this day, scientists can only speculate as to what happened to the orbiter. A craft sent to study the climate and weather patterns of the Martian atmosphere. Some say that because the orbiter dropped down to within 36 miles, 60 kilometers, of the planet, about 62 miles, 100 kilometers, closer than planned, atmospheric friction probably overheated the propulsion system and tore the vehicle apart. Others believe the craft was propelled through the atmosphere, or bounced off and out into space again, and is now perhaps circling the Sun like an artificial comet.
What is computational ecology?
Computational ecology can be considered a subset of environmental modeling, because it addresses practical questions arising from environmental problems using mathematics. For example, in the field of ecotoxicology, mathematical models are used to predict the effects of environmental pollutants on populations. Natural resource management uses mathematics to set quotas for fish and game. And conservation ecologists use mathematical models to determine the effects of various recovery plans for threatened species, and even to design nature preserves.
What are the modern connections between architecture and mathematics?
The foundations of modern architecture began with mathematics. Mathematical planning goes into creating almost every working, freestanding structure. From the smallest monument to the tallest buildings and bridges. For example, in order to build a structure, the area where the building will be erected must be measured to see if it will fit. Measurements and surveys, then the building plans need to be drawn up in scale drawings made proportionally smaller to the structure's real size. For more information, see below, and the amount of building material must be estimated, mathematics to figure out the budget. Finally, the actual structure must be built to specifications so the building will stand without collapsing, geometry and measurement.
What is congruence?
In reference to numbers, Congruence is the property of two integers having the same remainder upon division by another integer. The term also is often used in geometry to describe a property of geometric formations. For more information about congruence in geometry, see geometry and trigonometry. Still another way of using congruence is in number theory, in which modular arithmetic is the arithmetic of congruences, which is sometimes informally called clock arithmetic.
What is scientific notation?
Scientific notation is a way of making larger and smaller numbers used in the scientific field easier to write, read, and take up less space in calculations. Scientists generally pick the power of 10 that is multiplied by a number between 1 and 10 to express these numbers. For example, it is easier to write 0.0002333452 as 2.333452 x 10 to 4. For more about scientific notation and power of 10, see Math Basics.
What is the factorial of a number?
A factorial is the product of consecutive natural numbers for all integers greater than or equal to 0. Factorials usually start with 1, the symbol for factorial is an exclamation point. For example, 4 factorial, 4, is 1x 2x 3x 4, or 24. In the numerical system, consecutive factorials are 1, 1, equals 1, 2, 2, equals 1x2, 6, 3, equals 1x2 x3, 24, 4, equals 1x2 x3 x4. 120, 5, equals 1x2 x3 x4 x5, 720, 6, equals 1x2 x3 x4 x5 x6, 5040, 7, equals 1x2 x3 x4 x5 x6 x7. 40,328, equals 1x2 x3 x4 x5 x6 x7 x8, 362,880, 9, equals 1x2 x3 x4 x5 x6 x7 x8 x9, and so on. There are two additional rules: the number 0 factorial, 0, equals 1. And the factorial values for negative integers are not defined. Factorials are most often used in reference to counting numbers. Statistics, especially in probability calculations, calculus, and physics.
What are some of the basic building blocks of geometry?
There are several basic building blocks of geometry, all of which have to do with the objects we often see in geometry. A zero-dimensional object that is specifically located in n-dimensional space using n coordinates is called a point. The idea of a point may be obvious to most people, but for mathematicians, describing and dealing with points is not straightforward. For example, Euclid once gave a vague definition of a point as that which has no part. Euclid also called the line a breadthless length, and further called a straight line one that lies evenly with the points on itself. Modern mathematicians define lines as one-dimensional objects. Although they may be part of a higher dimensional space, they are mathematically defined as a theoretical course of a moving point that is thought to have length but no other dimension. They are often called straight lines, or by the archaic term, a right line, to emphasize the fact that there are no curves anywhere along the entire length. It is interesting to note that when geometry is used in an axiomatic system, a line is usually considered an undefined term. For more about axiomatic systems, see Foundations of Mathematics. In analytic geometry, a line is defined by the basic equation x plus y equals c, in which a, b, and c are any number, but a and b can't be zero at the same time. A line segment is the shortest curve which is actually straight to connect two different points. It is a finite portion of an infinite line. Line segments are most often labeled with two letters corresponding to the endpoints of the line segment, such as a and b, and written as a b. Distance is the length of the path between 2 points, or the length of a segment, for example, between points A and B. When talking about the distance between any 2 points associated with A and B as real numbers, on a number line, distance becomes the absolute value of BA. Another basic building block is the ray. Think of a ray as a laser beam. It originates at one point and continues in one direction toward infinity. A ray is defined as part of a line on one side of a point, and includes that point. 2 letters are needed to name a ray. For example, ray of is defined by point A, where it begins, and point B, the point the ray goes through. But note, ray of is not the same as ray BA. If the initial point is not included, the resulting figure is called a half-line. In geometry, a ray is usually considered a half-infinite line, with one of the 2 points A and B taken to be at infinity.
The theorem gives the probability that a pair what are mutually exclusive events.
Mutually exclusive events are those that are impossible to occur together. For example, a subject in a study of male and female humans can't be both male and female. Males are males, females are females. Thus, depending on what the study is about, such as a study of how many males versus females go to college from a certain high school, both events will be mutually exclusive.
What is a point spread?
A point spread is the predicted scoring difference between a game's two opponents. It is used by bookmakers to equalize two teams for betting purposes. For example, if a person chooses the team that is favored, the gambler has to win by more than the point spread in order to get credit for a correct pick. If the underdog team is chosen, the bettor must lose by less than the spread number in order to get credit for a correct pick. If a point spread is listed as off, this means there is no official point spread for the game. For example, if a person picks Army to win, and the team is favored to beat Navy by 5 points, called a spread of 5 points, Army must win the game by 6 or more points in order for the bettor to win. If Army wins by exactly 5 points, the game is called a push, and no one wins.
What is Euclidean geometry?
Euclidean geometry is named after Euclid, the famous Greek mathematician. It is geometry mostly based on Euclid's fifth postulate, the parallel postulate, and is sometimes called parabolic geometry. Plane geometry is described as two-dimensional Euclidean geometry, while three-dimensional Euclidean geometry is known as solid geometry.
What is topology?
In general, topology is a branch of mathematics that examines patterns of geometric figures based on position and relative position without regard to size. It has also been called rubber sheet geometry because objects examined in topology are under continuous transformation. Also called topological transformation or homeomorphism. The shapes can be stretched, bent, and twisted in various ways, as long as they are not torn or cut as they are changed. For example, a circle is considered to be topologically equivalent to an ellipse. It can be deformed by stretching, and a sphere is equivalent to an ellipsoid. This includes changing an object based on a one-to-one correspondence. For more about changing such shapes and one-to-one correspondence, see elsewhere in this chapter.
What is the definition of a clock?
A clock, from the Latin clicca, or bell, is an instrument we use for measuring time. There are actually two main qualities that define a clock. First, it must have a regular, constant, or repetitive action, or process, that will effectively mark off equal increments of time. For example, in the old days before our battery-driven, analog and digital clocks and watches, clocks included marking candles in even increments, or using a specific amount of sand in an hourglass to measure time. Second, there has to be a way to keep track of the time increments and easily display the results. This eventually led to the development of watches, large clocks such as Big Ben in London. England, and even the clocks that count down the new year. The most accurate clocks today are atomic clocks, which use an atomic frequency standard as the counter.
How is a curve defined in geometry?
A curve is a continuous collection of points drawn from one-dimensional space to n-dimensional space. It is also considered an object that can be created by moving a point. But note, our usual use of the word curve does not mean a straight line. But in mathematics, a line or triangle is often referred to as a curve. Different forms of geometry define curves in various ways. Analytic geometry uses plane curves such as circles, ellipses, hyperbolas, and parabolas, which are usually considered as the graph of an equation or function. The properties of these curves are largely dependent on the degree of the equation in the case of algebraic curves. Curves with algebraic equations, or on the particular function. As in the case of transcendental curves, curves whose equations are not algebraic. Even more complex are space curves, all of which require special techniques used only in differential geometry. Will be the same as from B to A, and the distance between the points does not change if they are totally shifted over in one direction. Such a sliding over of the points is called translation. For more on this, see elsewhere in this chapter. In addition, the Pythagorean theorem is valid for 3 points that are the vertices. The intersection points of the sides of an angle, of a right triangle.
Why can't you divide by 0?
Dividing by 0 is like the old saying, you can't get something from nothing. Mathematically speaking, it's the same way, you can't divide by nothing. In fact, when something is divided by 0, the answer is always undefined. Here are a few ways of looking at this. There is a rule in arithmetic that a, b/a, equals b. So if we say that 1/0 equals 5, then 0, 1/0, equals 0 x 5 equals 0. In other words, if you could divide by 0, this rule would not work. Another way to look at the no to 0 as a divisor problem is through multiplication. If 10 halves equals 5, we know that 5x2 equals 10, the same for 5/1 equals 5, thus we know that 5x1 equals 5. But if you take 5/0, that would mean that the answer times 0 would equal 5, but anything times 0 is equal to 0. Because there is no answer to this dilemma, mathematicians say you can't divide by 0.
What is the casino's or house edge?
A casino is a gambling facility that normally includes all or a combination of the following: slot machines, video games, card games, and other games such as Keno, craps, and bingo. In order to make the casino the major money maker, not the gambler, there are certain rules of the casino, including the casino's edge, otherwise known as the house edge. The house edge is the ratio of the expected player loss to the initial amount bet. It is an exact measurement, usually expressed as a percent, of the casino's advantage in a game. A casino earns money by paying winners at house odds, an amount that is slightly less than the true odds of winning the game. There are definitely exceptions to this rule, which is why there are professional gamblers. But the majority of the time, the casino has the advantage. For example, if the house edge for blackjack or slots is 5%, then for every $100 bet initially made, the player can expect to lose $5. This not only helps the casino, but it is sometimes a way for patrons to compare one game to another, and even estimate how much they may lose. Of course, this is not always so straightforward. Some people win and others lose in the short run. But the casino always wins in the long run. There are also exceptions because of the way a game is played, such as in craps, see below. The best scenario would be to have no house edge, or an edge against the house.
What are the multiplication rules of probability?
In probability theory, the multiplication rule is used to determine the probability that two events, A and B, both occur. As with the addition rules, the notation for multiplication rules of probability are most commonly seen in terms of sets. P, A and B, equals P, A B, P, B, or P, A and B, equals P, B A, P, A, in which P, A represents the probability that event A will occur, P, B, represents the probability that event B will occur. And P, A and B, is translated as the probability that event A and event B will both occur. In addition, P, A, B, is the conditional probability that event A occurs given that event B has already occurred. And P, B, A, is the conditional probability that event B occurs given that event A has already occurred. Similar to the addition rules, if there are independent events, or those that have no influence on one another, the equation reduces to P, A and B, equals P, A, P, B.
What are calories?
To most people, calories are usually associated with a very large piece of chocolate cake. But in that case, they are called nutritionists' calories, or the unit of energy producing potential, equal to the amount of heat that is contained in food and released upon oxidation by the body. The body needs the calories in the foods we eat to use as energy. This is why nutrition and weight control texts often contain such entries as a 140-pound person walking for 1 hour at a moderate pace burns off 222 calories. In chemistry, a calorie also refers to a unit of energy. But in terms of chemical experiments, a calorie is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius from a standard initial temperature at a pressure of 1 atmosphere, sea level. The unit measurement for energy is a joule, in which 1 calorie equals 4.184 joules, 1 joule is translated most often in metric, as the energy needed to lift 2000 grams a distance of 10 centimeters.
When was the equal sign introduced into mathematics?
He equals sign, smiley face, is a relatively new invention in mathematics. It was first used by British mathematician Robert Record, 1510 to 1558, also seen erroneously as record. In his book The Whetstone of Wit, 1557, the first algebra book introduced in England. In it he justifies using two parallel line segments because no two things can be more equally. Sick, because no two things can be more equal than parallel lines. It was not an immediately popular symbol, though, with mathematicians continuing to use a range of symbols for equal, including the two parallel lines. Used by Wilhelm Xylander in 1575, and AE or OE, both from the word equalis, the Latin for equal. But for the most part, the word equal was written in an equation until around 1600. When Record symbol became more readily accepted, and it continues to be so today.
The problem with this proof?
If x equals y, then xy equals 0. Notice that halfway through the proof, the equation was divided by xy, which makes the proof erroneous.
What are hyperbolic and elliptical geometry?
Hyperbolic and elliptical geometry are the non-Euclidean alternative geometries mentioned above. The first alternative is to allow two parallels through any particular external point or hyperbolic geometry. This studies two rays extending out in either direction from a point P and not meeting a line L, thus, the rays are considered to be parallel to L. This also helps prove the theorem that the sum of the angles of a triangle is less than 180 degrees. It is called hyperbolic because a line in the hyperbolic plane has 2 points at infinity. This is similar to drawing a hyperbola that has two asymptotes. The second alternative, called elliptical geometry, has no parallels to a given line L through an external point P. In addition, the sum of a triangle's angles is greater than 180 degrees. Sometimes called Riemann's geometry, who developed the idea even further, see below. It is called elliptic in general because a line in the plane of this geometry has no point at infinity. where parallels may intersect it, which is similar to an ellipse that has no asymptotes. For more information about hyperbolas, ellipses, and asymptotes, see elsewhere in this chapter.
What are the properties of logarithms?
Logarithms have certain properties, depending on the interpretations of an equation. The following lists some of the most common properties. These rules are the same for all positive bases. Log 1 equals 0, because a equals 1. For example, in the equation 140 equals 1, the base is 14 and the exponent is 0. Because a logarithm is an exponent. This would mean the equation can be written as a logarithmic equation, or log 14 1 equals 0, 0 is the exponent.
What is radioactive decay?
Mathematics can also be applied to radioactive substances found within certain rocks. Radioactive decay is the disintegration of a radioactive substance and the emission of certain ionizing radiation, such as alpha or beta particles or even gamma rays. Simply put, when rocks form, the minerals within the rock often contain certain radioactive atoms that decay at a specific rate. Radioactive decay is especially important in radioactive dating, in which the original and decayed radioactive elements are used to determine the age of the rock. This is because certain radioactive elements will decay to a mixture of half the original element and half another element, or isotope, in a specific time frame. This is also called the half-life of the original element. For example, half of the uranium-238 in a rock will decay into lead-207 in 704 million years. Thus, the half-life of uranium-238 is said to be 704 million years. Statistically, this change follows a specific decay function for each isotope of an element. And in each of these exponential functions, the time for the function's value to decrease to half is constant, making radioactive dating perfect in determining the age of certain rocks.
What is the world's longest suspension bridge?
Ten years after construction began, Japan's Akashi Kaikyo Bridge, also known as the Pearl Bridge, was finally opened on April 5, 1998. It is the longest suspension bridge in the world, stretching 12,828 feet, 3,910 meters, across the Akashi Strait to link the city of Kobe with Owajishima Island. Its main span length, or center section, which is the way world's longest status is determined, reaches 6,532 feet, 1,991 meters, between support columns. The span length is almost a quarter mile longer than the previous record holder, the Storebælt. Great Belt East Bridge, in Denmark, which also opened in 1998. but this bridge may eventually lose its top dog status. The Italian government has approved plans to begin building what will be the longest suspension bridge in the world between mainland Italy and Sicily. It will be quite an engineering feat, with the main span stretching just over 10,827 feet, 3,300 meters. Interestingly enough, Japan and Italy are known to be tectonically active, with both receiving more than their fair share of volcanic eruptions and earthquakes, as well as, in Japan, tsunamis.
What is physics?
Physics is often described as the science of the interactions between matter and energy. It includes the subfields of atomic structure, heat, electricity, magnetism, optics, and many other phenomena. Traditionally speaking, physics is divided into classical and modern, although many subdivisions of the two overlap and both are ruled by mathematics. Classical physics includes Newtonian mechanics, thermodynamics, acoustics, optics, electricity, and magnetism. Modern physics includes such fields as quantum field theory and relativistic mechanics. Other common divisions of physics are experimental and theoretical physics. Theoretical physicists use mathematics to describe the physical world and predict how it will behave. They depend on experimental results to check, understand, change, or eliminate theories. Experimental physicists test their predictions with practical experiments, often using mathematics to conduct the experiments.
What is an algebraic structure?
An algebraic structure is made up of a set, collection of objects called elements. For more information about sets, see Foundations of Mathematics, together with one or more operations on the set that satisfy certain axioms. The algebraic structures get their names depending on the operations and axioms. For example, algebraic structures include fields, groups, and rings, as well as many other structures with strange names such as loops, monoids, groupoids, semigroups, and quasi-groups.
What are subjects and predicates in Aristotelian logic?
In Aristotelian logic there are grammatical distinctions between a subject and a predicate. The subject is usually an individual entity, an object, house, city, man, animal, or it may be a class of entities, objects, houses, cities, men, animals. The predicate is the property or mode of existence that does or does not exist with a given subject. For example, a singular plant, subject, may or may not be blooming. Predicate, all houses, subject, may or may not have 2 stories, predicate.
What is Newton's law of universal gravitation?
As hard as it is to comprehend, almost everything in the universe is attracted to everything else. This physical law is not only one of the most well-known but also one of the most important. Newton's law states that the gravitational force between two masses, m and m, is proportional to the product of the masses and inversely proportional to the square of the distance, r, between them.
What is pi and why is it important?
Pi is the ratio of the circumference to the diameter of a circle.
What are first-order homogeneous and non-homogeneous linear differential equations?
These differential equations may be long-winded phrases, but they are actually types of first-order differential equations. A first-order homogeneous linear differential equation can be written in the notation as follows. Ty, t, plus a, t, y, t, equals 0. The first-order homogeneous linear differential equations are those that place all terms that include the unknown equation and its derivative on the left-hand side of the equation. On the right-hand side, it is set equal to 0 for all t. The non-homogeneous linear differential equations are those that, after isolating the linear terms containing y, t, and the partial differentials inside the above large parentheses on the left side of the equation, do not set the right-hand side identically to 0. It is often represented by one function, such as the b, t, see below. The standard notation is as follows: ty, t, plus a, t, y, t, equals b, t, usually in reference to time. Such problems are called initial value problems. The other condition is the boundary condition, in which constraints are specified this time at the boundary points, usually in reference to space, with such problems called boundary value problems.
Is math used in accounting?
Yes, math is definitely used in accounting. The field includes the classification, analysis, and interpretation of the financial records or bookkeeping of an institution, company, or other enterprise, with most of the mathematics being addition and subtraction. Bookkeeping records not only tell the financial health of an organization in terms of profits or losses but are also used for auditing and the occasional balancing of a company's ledger from a set period of time. Bookkeeping has a long history. The idea was probably understood long before mathematician Luca Paciola's c. 1447 c. 1517, treatise on bookkeeping was published in 1495, for more about Paciola, cp. 374. the idea of a double-entry bookkeeping system or a debit from an account and a corresponding credit in another account is popular today, but it was first used in medieval Europe.
What other way did Archimedes use to find the area of a circle?
The Greek mathematician Archimedes, c. 287 to 212 BCE, Hellenic, also found a way to determine the area of a circle similar to the Chinese comb. A method he first recorded in his work, Measurement of a Circle, c. 225 BCE. He also used a sequence of wedges to determine the area of a circle, as the number of wedges or triangles inside the circle increased toward infinity, they became infinitely thin. By giving each small triangle a base, b, a line connecting the points where the wedges touched the circle's circumference, he determined that the area was 1/2 times the radius r times the base, summed over all the infinitesimal triangles, or sum, 1/2, rb. Because they all had the same height, that was factored out. Thus, the area became 1/2 r sum b equals 1/2 rc, with c being the circumference, or the sum of the bases b of all the triangles, since the bases make up what is perceived as the circle's circumference.
How old is the study of fluid mechanics?
According to many historians, fluid mechanics may be the oldest subfield in physics and engineering. In particular, ancient civilizations needed to control water flow for agricultural development, drinking water supplies, and transportation. Thus, the development of fluid mechanics, which is the study of the motion and behavior of fluids, led to even more, and complex, improvements. For example, agricultural requirements led to irrigation waterways, dams, weirs, pumps, and even crude forms of sprinkler systems. The need for a potable, drinkable, water supply led to better wells, fountains, and water storage systems, and water transportation innovations included improved sails and rigs, as well as methods to build and waterproof sailing vessels. But early fluid mechanical studies did not end there. Over time, they extended into almost every realm of science and engineering. For example, mechanical engineering uses fluid mechanics because of the need to know about fluids used in combustion. Ships and automobiles, lubrication, from the smaller inner workings of a wheel to larger mechanisms such as locks along a canal, and energy systems, hydroelectric power. Civil engineering utilizes fluid mechanical studies to interpret how fluid systems traveled over structures. Aqueducts and pipes carrying drinking or waste water. Electrical engineers use fluid flow to analyze how to cool electronic devices with either air or water. Even early, and current, aeronautical engineers needed to know how air flowed over an airplane wing. providing the much-needed lift that allows a plane to become airborne.
What is mathematical analysis?
Mathematical analysis is a branch of mathematics that uses the concepts and methods common to the field of calculus. The key to mathematical analysis is the use of infinite processes, in turn. That involves passage to a limit, or, in other words, the basic branch of calculus. For example, a circle's area can be thought of as the limiting value of the areas of regular polygons within the circle. As the number of the polygon sides increase indefinitely. The reason for calculus is simple, it is one of the most powerful and flexible tools not only in mathematics but in virtually every scientific field.
Who was M. C. Escher?
Moritz Cornelius Escher, 1898–1972. Was a Dutch painter famous for his mixing of art and mathematical concepts. He had no formal math training past secondary school, but he was, and still is, admired by mathematicians for his amazing visualizations of mathematical principles. Escher's interest in mathematical patterns began around 1936, after viewing the Alhambra Palace's collection of Islamic art, see above. He was fascinated with structures represented in plane and projective geometry, both Euclidean and non-Euclidean geometry. For more information, see geometry and trigonometry. Not only using the geometry of space, but also the logic of space. For example, he used the idea of tessellations, or arrangements of closed shapes, usually polygons or similar regular shapes, like those used on a tiled walkway, that cover the entire plane without overlaps or gaps. Not only did he use regular tessellation shapes, but also irregular ones, making the shapes change and interact with each other. He also made many of his amazing patterns by taking a basic pattern and either distorting it and/or applying what geometers call reflections, translations, and rotations. For many other mathematical patterns, he used regular solids, Platonic solids, and visual aspects of topology in his work. For more about Platonic solids, see geometry and trigonometry.
Where did the symbol for infinity originate?
Infinity is represented by the symbol OO. A sign introduced by John Wallis in 1655 in his treatise De Sectionibus Conicus. Historians believe that Wallis, a classical scholar, adopted the sign from the late Roman symbol for 1,000. Whether it was from there or another source, the result was and remains, the same, a figure 8 on its side, as many people describe the infinity symbol.
What is the notation commonly used for series and sequences?
When looking at a sequence and series, we need to distinguish between the ones we want to add, and the ones we do not want to add. The common symbol used for addition with a sequence or a series is the summation symbol, seen as the symbol. When discussing a series, this symbol is used to mean the sum of numbers.
What is the annual percentage rate, or APR?
The annual percentage rate, APR, is an expression of the yearly interest rate that will be paid on a loan, which includes credit cards. It differs from the advertised interest rate, as it includes one-time fees in an attempt to calculate the total cost of borrowing the money. Therefore, it is wise to always look for a low APR. Because lenders are required to disclose the APR before a loan or credit application is finalized, it makes it easier to compare lenders. For example, if a person borrows $100 for 1 year at 5% simple interest, they will owe $105 at the end of the year, and the lender charges a $5 fee. The total cost to borrow the money will actually be $10, meaning the APR is 10%.
How is mathematics used to determine resistor values in an electrical network?
Electrical engineers who deal with systems and circuit theory need to know the terms and functions of the basic circuit element resistor, capacitor, and inductor in terms of current voltage associations determined by impedance, obstruction. Complex numbers, calculus, and Laplace transforms, see above, are all mathematical concepts used to understand circuit theory. The best way to understand the basics are through the following simple equations. Resistor voltage equals current, I, times resistance, R, or V equals IR. Capacitor voltage equals the square root of -1, J, often called I, or an imaginary number, times frequency. W, times the capacitance, C, all times the current, I, or V equals, JWC, I. Inductor voltage equals the current divided by the square root of -1, J, times frequency, W, times inductance, L, or V equals I/JWL.
Have there been different types of absci over the centuries?
Yes, there have been many different types of absci over the centuries, including the Roman absci mentioned above. The first type of abacus came into use in China about 1300 and was called a suan pen. Historians do not agree as to whether it was a Chinese invention or not. Some say it came from Japan via Korea. Although merchants used this type of abacus for standard addition and subtraction operations, it could also be used to determine square and cube roots of numbers. The Japanese abacus, or soroban, was similar to the Chinese abacus, but it eliminated one bead each from the upper and lower deck in each column. Thus, it is more similar to the Roman abacus. The Russians also have their own version of an abacus. It uses 10 beads on each wire, and a single deck. The separation in the wires is created by one wire with fewer beads.
What are the various methods of keeping time?
There are three basic methods of keeping time in common use today. They include time based on 12-hour intervals, AM and PM, a 24-hour clock, and coordinated universal time clock, called UTC or Zulu time. All of these have to do with simple mathematics, mainly addition and subtraction. A 12-hour clock, using the 12-hour interval concept, is familiar to most of us. It represents half a day, 24 hours divided by 2. The abbreviations AM and PM terms that originated from the use of longitudinal meridians are used to differentiate between the morning and afternoon hours. The term meridian, from the Latin meri, a variation of medius, or middle, and diem, or day, once meant noon. Thus, the time before noon was called ante-meridiem and afternoon was called post-meridiem. They were eventually shortened to AM and PM, respectively. Whether the terms are capitalized or not is not an issue either, as both are used in texts. The 24-hour clock is, naturally, divided into 24-hour increments. It is commonly used by the military and other government agencies throughout many countries. UTC, or Coordinated Universal Time, the letters are not a true abbreviation, but a variant of universal time, is equivalent to mean solar time at the prime meridian. 0 degrees longitude, formerly expressed as GMT, or Greenwich Mean Time. The change was done to eliminate using the name of a specific location in an international standard. Other names for UTC are World Time, Zulu Time, and Z Time. UTC should not be confused with UT, or Universal Time. The basis for the coordinated broadcast of time signals, counted from 0000, or midnight.
What are some examples of weather prediction models?
Because there is more than one group carrying out weather predictions. There are many computer models used by meteorologists around the world. For example, the United States National Weather Service's weather predictions. are carried out at the National Centers for Environmental Prediction, NCEP. The NCEP runs several different computer models each day to determine the best weather forecasts. Some are used for short-term forecasting, others for the longer term. And some are used for global or hemispherical predictions, while others are only regional. They include several mathematically intensive computer models. For more information about computer modeling, see Math in Computing. NGM, or the nested grid model, is one in which observations are converted to values at various points that are evenly spaced, making it easy for the computer programs to plug them into equations. This model is now considered to be obsolete. ETA. The ETA model was named after the ETA coordinate system, which is a mathematical coordinate system that takes into account topographical features, such as mountains. It is similar to the NGM model and forecasts the same atmospheric variables, but its smaller grid gives a more detailed forecast. AVN, MRF, and GSM. The AVN model, MRF, medium range forecast, and the GSM, global spectral model, convert data into a large number of mathematical waves. They then return the waves in a manner that will produce a forecast map. ECMUF. The ECMUF, European Centre for Medium Range Weather Forecasts, is considered to be one of the most advanced weather forecast models in the world. It is mostly used for the Northern Hemisphere. UKMET. The UKMET, United Kingdom Meteorology Offices model also gives forecasts for the entire Northern Hemisphere. MM5. The MM5, Mesoscale Model Number 5, and WRF, Weather Research Forecast Model, are actually the same models. The MM5 has long been a research computer model for smaller geographic forecast regions such as Antarctica. The WRF is the name for MM5 as an operational model, not just for research.
What is the derivative of a function?
One of the most important, core concepts in modern mathematics and calculus is the derivative of a function or a function derived from another function. A derivative is also expressed as the limit of dy/dx. Also said as the derivative of y with respect to x. It is actually the rate of change, or slope on a graph, of the original function. The derivative represents an infinitesimal change in the function with respect to the parameters contained within the function. In particular, the process of finding the derivative of the function y equals f, x, is called differentiation. The derivative is most frequently written as dy/dx, it is also expressed in various other ways, including f, x, set as the derivative of a function f with respect to x, y, df, x, df, x, or dxy. It is important to note that the differentials, written as dy and dx, represent singular symbols and not the products of the two symbols. Not all derivatives exist for all values of a function, the sharp corner of a graph. in which there is no definite slope and thus no derivative is an example.
What are identity and conditional equations?
Identity and conditional equations are ways in which numbers associate with each other. When an equation is true for every value of the variable, then the equation is called an identity equation. It is often denoted as I or E, the E is from the German Einheit, or unity. For example, 3x equals 3x is an identity equation, because x will always be the same number. 0 is the identity element for addition, because any number added to 0 does not change the value of any of the other numbers in the operation, or x plus 0 equals x. The number 1 is the identity element of multiplication. As any number in an operation multiplied by 1 does not change the value of that number. Multiplication identity is often written as x1 equals x. When an equation is false for at least one value, it is called a conditional equation. For example, 6x equals 12 is conditional because it is false when x equals 3, and any number other than 2. In other words, if at least one value can be found in which the equation is false, or the right side is not equal to the left side, then the equation is called a conditional equation.
What is a frequency table?
A frequency table is a way of summarizing data. In particular, it is a way of displaying how entities, such as scores, number of people, etc., are divided into intervals, and of counting the number of entities in each interval.
What are some non-Hindu Arabic numerals encountered around the world?
Although Hindu Arabic numerals are the dominant numerals used around the world, there are some places in which other number symbols are used. For example, there are Chinese, Japanese, Kanji, Greek, Thai, and Hebrew numerals. The illustration lists some of the ones encountered by world travelers. For more information about numbers, see Math Basics.
What is an array?
A mathematical array is a list of lists, or a rectangular arrangement of objects. It is a useful way of keeping a collection of things. Arrays are orderly arrangements of objects in columns and rows, with the objects most often being numbers. For example, the most common arrays are two-dimensional with a certain amount of rows and columns. In this case, this is a 2 by 3 array, rows are always mentioned before columns. The order of numbers and slash or elements in an array may sometimes, but not always, be significant, as it is in a matrix, see below.
What is a solution?
When an equation has a variable, the number that replaces the unknown and makes the equation true is called a solution. For example, for the equation, 5xy, plus 2 equals 12, y would be 2. Or 2 is the solution that makes the equation true. To work this out, the process would look like this: 5x2, plus 2 equals 12, 10 plus 2 equals 12, and, finally, 12 equals 12. Remember, when finding a solution for an equation, one must follow any parentheses. Exponents, multiplications, divisions, additions, and subtractions in the correct order of operation.
What are cardinal and ordinal numbers and finite sets in set theory?
Cardinal and ordinal numbers are used in reference to numbers. Ordinal numbers are used to describe the position of objects or entities arranged in a certain sequence, such as first, second, third, and so on. Cardinal numbers are natural numbers, or 0, 1, 2, 3, and so on. For more information about cardinal and ordinal numbers, see Math Basics. But cardinal numbers used in set theory describe the number of members in a set. Both ordinal and cardinal numbers are further used to describe infinite sets and are prefaced with first ordinal or first cardinal infinities. The first ordinal infinity applies to the smallest number greater than any finite ordered set of natural numbers. The first cardinal infinity applies to the number of all the natural numbers. For more about infinite sets, see below. A finite set is one that is not infinite. It can be numbered from 1 to n, for some positive integer n. This number n is also called the set's cardinal number, thus. For a certain set A, the cardinality is denoted by card A. There are a number of rules to cardinal numbers and finite sets. For example, if two sets bisect, then they are said to have the same cardinality, or power. The empty set is considered to be a finite set, with its set's cardinal number being 0.
What is the story behind the Mersenne primes?
Mersenne primes, or Mersenne numbers, are connected to prime numbers. They come in the form of 2p1, in which p is a prime, or, to put it another way, when 2p1 is prime, it is said to be a Mersenne prime. Centuries ago, many mathematicians believed that numbers from the form 2p1, they actually used the form 2n1, which is the same as the 2p1 used today, were prime for all primes p. By the 16th century, it was proven that 211 1 equals 2047 was not prime. By 1603 Pietro Cataldi, 1548 to 1626, correctly discovered that p equals 17 and p equals 19 were both prime. but he was wrong to add 23, 29, and 37 to his prime numbers list. Soon, others discovered his errors, including French mathematician Pierre de Fermat. 1601–1665, in 1640, and Swiss mathematician Leonard Euler, 1707–1783, in 1738. The hunt for primes continued. The name Mersenne actually came from the French priest Father Marin Mersenne, 1588–1648. who in 1644 referred to such numbers in the preface to his book Cogitata Physica Mathematica. He believed that these special primes were p equals 2, 3, 5, 7, 13, 17, 19, 31, 67, 127, and 257. But like earlier attempts at determining prime numbers, many of Mersenne's numbers were in error. It took 3 centuries more to check Mersenne's range of numbers, and by 1947 the correct list of Mersenne primes were p equals 2, 3, 5, 7, 13, 17, 19, 31, 61, 89, 107 and 127. Interestingly enough, even though Mersenne incorrectly stated that certain numbers belonged to this group, he probably didn't verify all the numbers on his list. His name is still attached to these numbers.
What are the probability and odds of drawing a certain card from a deck?
The probability of an event is usually described as the chances for the event to occur over the total chances for the event to occur, chances for/total chances. In the case of a deck of 52 cards, the probability of drawing a king from the deck is 4/52 equals 1/13 equals 0.077, or 7.7%. As seen above, the odds, or the ratio of chances for to chances against, chances for, chances against, can be found by the formula, total chances equals the chances for plus chances against, or total chances equals chances for plus chances against, or chances against equals total chances for. Thus, the odds of picking a king from a deck of 52 cards is 4/52 equals 4/48 equals 1/12.